Hello everyone. In today's lecture, we're going to study about uh, what a blockchain is. So, blockchain can be defined simply as a distributed and immutable ledger. Now, what do I mean by that? By that, I mean to say that blockchain can be defined as a distributed and an immutable. Distributed means that is present at all the nodes or all the systems that are present in the blockchain, and immutable means that it is unchangeable. So, I would like to explain this using the following diagram. Like for example, we look at a banking system, and now this banking system has a centralized authority. This banking system has a centralized authority, and the records of the transactions are present in this centralized authority. Let's suppose we have four customers for this: A, B, C, and D. So we have four customers for this, and all of these are using this banking system, this centralized banking system, and they are all dependent upon this. They are dependent upon this centralized authority. Now, there is one issue, like for example, if this banking system crashes, so the entire system will not work. And another thing, there is only one central authority, and this banking system cannot be trusted. Like for example, if it tries to change some of the documents or some of the transactions, it cannot be trusted, and is not a trustworthy source, because the trust is dependent upon only one centralized system here. Now, when we look at the blockchain system, what blockchain system does, it has a central ledger. Let's suppose we have all the nodes present. We have the nodes A, B, C, and D, and all of these are connected to this banking system. So in blockchain, what it will have, we will have a distributed ledger, which means that they are connected to each other, and they are also connected to the centralized ledger here. So let's suppose if A wants to send D some money, or A wants to send B some money, or A wants to send C some money, it can directly send. Let's suppose A wants to send D a money of 1 Bitcoin, so it can directly send it this money without any centralized authority involved. But what is this copy of the ledgers and the centralized ledger? The main thing that here it is that when A wants to send D some money, like it wants to send 1 Bitcoin to D, how it does that is, it makes a block. It makes a simple block, and this block acts as a transaction. Like let's suppose in the banking system, A had to send C some money, that was put as a transaction or as a record in this banking system. Now in the blockchain, that one single record is known as a block. Like let's suppose A was sending some money like 1 rupee to C, that transaction was added to the banking system as a record. It was added to the banking system as a record or a transaction. So when you see the case of a blockchain, that record or that transaction is seen as a block. This is the difference. This is the only difference here. And uh, what will this block contain? This will contain the data of the transaction, which is A has sent 1 Bitcoin to D, and it will contain a hash value. What is this hash value? This hash value is a cryptographic hash. It is created from the cryptographic hash function. It is created using a function, and this hash value, it is of a fixed length. For each of the blocks in the blockchain, it will be of the fixed length. Like, let's suppose it will be of 256 bytes. Whatever be the size of the data, this hash function will be the same, and it will have a previous hash function. It will have a previous hash function, and this will be the hash function of the previous block in the blockchain. Let's suppose A has sent B some data. So in the blockchains, we already had one of the blocks. For example, in the blockchains, we already had one of the blocks, and let's suppose that had the hash function h0, and that had the data, and that had the previous hash function. Let's suppose ph. It has the previous hash function ph. Now if in a blockchain there is the first block, which will have no previous hash function, because it's the first block. It will have a previous hash function of all zeros, and that is known as the genesis block, which is the first block in the blockchain. That is known as the genesis block, and it will have its hash function, the data, and the previous hash function will be here, for example all the zeros. Now this is present in all the copies of the block. This will be present in all the copies of the block of the ledger. It will be present in all the copies of the ledger, this data. And now it will also be present in the centralized ledger. It will also be present in the centralized ledger. Now when A sent D amount of money, which is 1 Bitcoin, it has added to its ledger this value. So it will have its hash function, for example h1, and it will have the transaction data. What will be the transaction data? A sent 1 Bitcoin to D. This will be the transaction data here. And what will be the previous hash function? Previous hash function will be h0. Previous hash function will be the h0 here. The reason for that is that the previous block in the blockchain, in this ledger or in this register or in this blockchain, the previous block is having the hash value of h0. Depending on its data, it is having the value h0, and this previous hash function will be h0 here. So they are connected to each other using this, using the previous hash function, and that's why it is known as a blockchain. The reason for this, that it is known as a blockchain, is that the blocks form a chain like structure here. The hash functions are connected to each other using the blocks are connected to each other using the hash function. So this defines the term block and the chain of blocks. Now this is only a single ledger here. Now when A has sent one Bitcoin to D and it has added the copy of the block in this. Now there is one thing we have to do here is that it has to broadcast this transaction, and this transaction must be broadcasted to all the ledgers here. So all of these ledgers will check this transaction and check this block, and they have to accept this block at least 50%, more than 50% uh, nodes in the ledger. A, B, C and D, they are seen as nodes, and all of these nodes in this blockchain, at least more than 50% have to accept this transaction, and only then this new block will be added to the blockchain. This new block will only then be added to the blockchain, like it will be added to all the nodes when it is accepted by more than 50%. It will be added to all the nodes, copy of the ledger, and it will be added to the central ledger also. If this is not the case, this transaction will be rejected. If this is not the case, this transaction will be rejected, and this process is known as consensus. This process is known as the consensus algorithm. And how that is done? Some of the algorithms are proof of work or proof of stake. This proof of work is used by Bitcoin, and this proof of stake, it is used by Ethereum. The proof of work is used by Bitcoin, and the proof of stake is used by Ethereum. And the use of all of these algorithms is to reach a consensus. By consensus, we mean to say that when uh, A has sent money to D, a new block has been added into this, the copy of A, the ledger or the register of A. A new block has been added. This block can be seen as a record or as a new transaction, but it has been added to the ledger of A. So when it has been added to ledger of A, it has been broadcasted to uh, all the distributed blockchains. But they have to add this, and they can add this only when they have reached, there has been a consensus reached, and that consensus is reached by proof of work and proof of stake. And this proof of work or proof of stake algorithm, all of this is handled or done by the nodes only. Those nodes that are present in the blockchain, these nodes only participate in this proof of work or proof of stake algorithm. And this is how a blockchain works. They add a block into the ledger, and then when consensus is reached that this A has actually sent one Bitcoin to D, and all of the miners, all the or the nodes, they accept this transaction, more than 50% accept, they can add that into their own copy of the ledgers, and it can be also added to the central ledger. So this is a distributed system. And when a central authority was present, like a banking system, it was prone to uh, loss of it was prone to uh, like any of the uh, loss of money or loss of uh, the trust, because there was only one central authority involved, so it was not that much trustworthy. And also whenever the banking server crashes, the system crashes. But here it is a distributed system, and if any one of the blockchain crashes, there are many other copies of the ledger or copies of the blockchain, and there cannot be loss of runtime. So Ethereum has never ever been off, or Ethereum has never ever crashed, because the reason is that if any one of the system crashes, it is a distributed system and all the other will remain there, and it is more trustworthy because there is no central authority involved, and the transaction prices are not in between that much present, because no centralized authority will charge you. The transactions can be directly done, and now each of the block is added based upon the consensus, so there is no untrustworthiness. When more than 50% of the blocks accept this transaction, only then this transaction will be accepted, and that will be added to the blockchain. Now the reason that it is immutable is that if you want to change a block in the blockchain, you cannot change that, because that will take a large amount of time. You have to change all the blocks in that blockchain, and then you have to change the blocks in the distributed ledgers also. For Bitcoin to change a block, you would take 10 minutes to change one block in this blockchain, and then you will take how many, there are millions of blocks in the Bitcoin. You will take 10 minutes to change one block. When one block is changed, all of the blocks will be changed, because this hash function will be changed. So you have to again change all the blocks. You have to reach the consensus for all the blocks, and that takes 10 minutes of processing work. And for the Bitcoin, there are millions of blocks, and there are millions of these copied ledgers. So it will take 200 years to change one block in the Bitcoin actually. So it is immutable. It cannot be changed. And to add another block, you use this consensus algorithm, which is based upon the proof of work and the proof of stake. Proof of work is used by Bitcoin, proof of stake is used by the Ethereum, and these algorithms are handled by the nodes themselves. Uh, Proof of work, it requires some processing power. Proof of stake also requires some processing power. But the main uh, basis of blockchain is this: it is not dependent on one centralized authority. It is it is decentralized. It is distributed, and it is more secure, and it is immutable. So all of these are the basis of a blockchain, the building blocks of the blockchain, and why it is more secure than the centralized banking system. uh, and It is not only used in the banking system. You can use it in the healthcare system to store the records of the patients, which cannot be changed again. You can use it in the university result system, the results of the students, because you cannot change that again. After that, it will be secure for that. Or you can use it to make record of the IDs of the people living in a country, because you cannot change that again. It will be secure based upon that. It can make a digital identity, like Microsoft uses it for that. You can use it for gaming, like Ubisoft uses for that, because it is more secure as compared to uh, normal things. So Bitcoin is not only used for the blockchain is not only used for the Bitcoin or the Ethereum, which are simply the digital money. It can be used for all the other purposes also, like I told you, for the healthcare, or for creating digital identity, like Microsoft does that, because it's or the result for the student, because it's immutable, unchangeable, and it is distributed. So there will be no downtime for this. uh, I hope you understood this basics of the blockchain. Thank you.